accumulated precipitation, the same as the Iberia, the same as the area of South and West France, but also Italy, but also the Balkans, and also this area of the world, which is suggested to be a hotspot. Yeah? So, mean precipitation is declining over the area of concern, which may suggest into a change in the biodiversity of what is cropped over the area of Europe. And that may result in hazard. How about the cryosphere? You in the Alps are living from winter tourists organized to climb the Alps, to do sports in the Alps. Alps have loosened more than 50% of the ice shelf during the last year. This is a significant finding. So this is going to result into economic losses from these countries, which is going to result into the development of these countries on investing on winter issues matters. And of course, observe that all the shelves, all the ice seeded in the present era, where we have this rapid climate change. At least humanity, what has the humanity at least has to do, has to acknowledge the problem and seriously think and act, which is not an easy task, as we follow a certain development growth model based on the fuels from Earth. We have to.
I'm Giulio Zuccaro, and a full professor at University of Naples of something that has nothing to do with what you say. It is solid and structural mechanics. I'm very old, and all my dear friends, Professor Pitilakis. However, I found your presentation very interesting, very, very actual, very, very update on what is one of the main problems that we are facing in these days. Actually, even the European Commission is driving their own call and funding for research in the Horizon Europe, but it was even in the Horizon 2020 that is very much stressing these issues. We were just discussing a few minutes before you came that the 80% of funding for research now are oriented on this kind of issues. And the most important thing is that now the risk is, the view of the risk, now is the risk is viewed as a whole. Disaster risk reduction by geohazard, so earthquake, volcanic eruption, or whatever, and climate change is seen as one single hazard, one single problem that has to face, because there are a lot of combinations. You have just said some of those. So climate change means precipitation, changement in precipitation, heat waves. For some of the precipitation, that is one of the main cause of severe and extreme events, and inundation and landslide, and many of these other typhoons and so on. So actually, it's true that the problem is one world problem, and it's true that the multi-risk analysis and cascading effect is more and more required by stakeholders. And so a good governance of local authorities and all the institutions that work on this require that this problem has to be seen as a whole problem, as an integrated problem. So what I want to say here is that the ISTOS project intend to establish in Cyprus a center of research, a center of competence, if this will be finally recognized by the institution, that could help all the institutions engaged in this problem, and you now are a very good selection of those. Probably not all, but a very good selection. And what we have focused in this project was earthquakes. You are a very seismic area, and earthquakes is very important. But what I want to underline, that the transfer of the best practice from the University of Thessaloniki, from the University of Naples to ISTOS, a Center of Research, is not finished in the earthquake modeling and simulation of seismic assessment, risk assessment. For instance, in our center of competence in Italy, we now have a lot of progress and project ongoing with Horizon Europe on climate change. We have just finished Clarity, that is a Horizon project on the modeling of heat waves consequences. And this model is available even on the website for free, for some rough idea on where to concentrate adaptation measure that the local governance could take in consideration for reducing the impact on the population, and also other measures that could influence the mitigation, so the reduction of CO2. And this is actually the topic of other two projects ongoing that we have, that is Knowing and Icaria. And this connection with ISTOS, I think is good because I presume, I hope, will be not finished at the end of the project, but will continue in this opportunity to transfer this and to have you on board in other projects. Another one is starting with ISTOS partnership on climate change, and that makes the difference. So not just only seismic, but climate change is climate power. Now we are in the negotiation phase. So this is just to tell you that is very, very interesting. We are very updated, and we are very pleased by our own, altogether with ISTOS project, to transfer this simulation model for adaptation measure, and we have developed a simulation on heat wave and urban flooding. Is another important issue that could contribute through ISTOS to give some information, some data on which you can think how to address the local authorities to govern and to prepare, program for adaptation, for mitigation, and for the best to do in the governance. Because obviously the urban planning depend on these parameters. You cannot think that you want to govern your town making urban planning without seeing that there is the seismic risk, there is the climate change risk. Everything is now anymore possible in any country of Europe. Thank you very much.
Thank you, Professor, for the underline you have made. First of all, we have to know that WMO, the World Meteorological Organization, strongly supports the common alerting protocols on multi-hazard warnings.
Okay.
So in Cyprus, we are connected with civil defense, with the Department of Geology, and with the health authorities in order to inform them on issues concerning early warning. And this is applicable when we have an orange and mostly red alert on the authority which meteorology has, heavy rain, thunderstorm, heavy precipitation, heavy thunderstorm, and so on and so forth. And the other is that all I have presented is are included into the latest issue of WMO resulting in the climate change over the area of Europe and the planetary. And of course, we have to do with a planetary thinking. We see the problem here, but we have to act globally. Yeah. And there are no magic solution. The other I wanted to say is that deliverables from programs must be sustained. The common problem is that when a program ends, the deliverables die.
That should be the starting point. Has to be. Has to be the starting point. That's right. Thank you.
For the Cyprus Civil Defense since 2009, I would like to introduce you my department. Our mission is to take preventive measures and supportive humanitarian measures also in order to protect the population, its property, as well as the environment and the critical infrastructure.
The ionospheric variability with respect to operational systems like HF systems, which are more or less military-based application communication systems. But later we have expanded the scope, the research scope of the group to other topics, like the remote sensing of the medium, the ionosphere, also in response to earthquakes, which is of course a big discussion in the community. Some part of the community is accepting the frameworks that have been proposed during the last, let's say, 20 years, following very, very big earthquakes, of course, very, very severe events that have an impact on the ionosphere through the atmospheric, let's say, cascading effect. And later, of course, based on the relevance with the discussions you had before, I also want to highlight the remote sensing techniques that we are exploiting with respect to another topic, which is extreme floods, severe precipitation events, which of course are relevant to the infrastructures that we deploy on the ground. So the ionosphere is a region which is composed of free electrons produced by UV radiation from the sun. In the night time, of course, it is sustained through recombination, which leaves a residue of electrons, which can be used to, it affects, let's say, operational systems like GNSS systems and navigation systems mostly, but it also serves the purpose of, let's say, being used as a mantle on which various manifestations of wave activity is imposed. And this is the idea based on which we have been exploiting this concept in the last 20 years to, let's say, monitor mostly cosmic events, which I would like to highlight here with respect to the latest Turkey earthquake, which we have studied with other European groups jointly to produce some publication, but also to give a highlight of the basic idea of this coupling of the atmospheric layers and also the coupling of the lithosphere. So this is a region between 60 kilometers and 1,000 kilometers, the main bulk of the electrons. It is an open system in the sense that it is affected by the magnetosphere, which sits on top, and it is the connection with the interplanetary medium and the sun, and the magnetic field of the sun, and of course during the high solar activity years like the one that we are actually going through these days, they are more relevant to geomagnetic storms that affect satellite systems and satellites which are affected by atmospheric drag. So this is the main topic of our research. But of course, because of the troposphere and the stratosphere and the intermediate atmospheric layers, you have this coupling effect with the lithosphere. And during the last 30 years, as I already mentioned, there have been mechanisms proposed by various groups which can be questioned by the general community. We actually collaborate a lot with INGV in Italy because it's a technology also related, let's say, institute, and also with NOAA in Greece. So this notion of the coupling is actually being established very strongly during the last 10 years, where the instrumentation allows for the higher spatial and temporal resolution of the measurements. So, as I told you before, there have been mechanisms that have been proposed highlighting mostly radon emission from the geological formations that are coupled, let's say, with the ionosphere through various mechanisms of association, of reduction of, let's say, other parameters like relevant to the electric field and also to the electron concentration, which also is coupled with the magnetosphere. So these effects are actually observed on top of the ionosphere. And there have been studies that have really established, especially for strong earthquakes, not only the cosmic notion, but also the precursory notion. But of course, this is questionable. It's a focal point of intense discussion in our groups. some of the atmospheric community is really accepting this, some other is rejecting this. That's why there have been recent influx of, let's say, funding from the European Space Agency to extend this investigation on satellite platforms like SOAR, data sets, and let's say other previous constellations like Cosmic and other constellations. So the most dominant model that is actually present is this like model, where we have the sort of proposal of these coupling effects based on different parameters. But of course the challenge here is to have sufficient measurements to formulate the parameters in a certain region which will cover the whole chain. And this is the main challenge that we are actually failing in our investigation to solidify the framework. That's why SSI topic in our group we have formulated this startup company which is focusing on low-cost GNSS sensor to encourage this extension of the exploitation of dense network and dense data, which I will show you a typical example of where we can really get benefit from this densification of measurements. So there have been studies that prior to earthquakes, a number of hours before, also a number of days before, we were able to identify some excursions from the median behavior, the average, let's say, nominal activity of the ionosphere, to establish, let's say, not only from the ionospheric perspective, but also from other perspectives, like, as I told you before, radon emission, and also other parameters that have been proposed by the community, specifically to tackle this coupling. Now, in our group, because we are primarily focusing on the ionosphere, so we are using these techniques to monitor the total number of electrons within a column of 1 square meter. So we are essentially measuring this integrated parameter, number of free electrons in the ionosphere. Is actually an estimation technique. It's not a direct measurement. Other than, of course, some specific cases like altimeter missions and provide the actual number of electrons, the other techniques that we have developed are estimation techniques in the sense that they are also dependent on the inaccuracies of the clocks of the satellites, of the clocks of the ground-based receivers, and also of the phase losses of log that we are subjected in this kind of measurement technique. So in the last 10 years in our group we have carried out studies on a localized scale around specific earthquakes. They don't show very clearly here, but we have carried out studies for very, very strong earthquakes. For example, the 3 earthquakes at Mexico that occurred in the interval 2016-2017. Very, very severe earthquakes. So that was the ideal scenario for us to try to investigate these signatures in the ionosphere, and we were able to pinpoint specific wave activity which is outside the regime which is ascribed to the geomagnetic storms I have mentioned before, or other meteorological, let's say, phenomena from below. So we are using, let's say, a framework which differentiates between different periods, frequencies of wave activity, to be certain on the origin, or more certain, let's say, on the origin of this phenomena, and try to ascribe them to earthquake activity. Also, on the larger scale, you can see that also our group and other groups have reported such a strong, let's say, impact which puts the 2 ionization anomalies of the ionosphere around the equator together. So this is a very unique signature that we are able to report. Now, of course, in order to solidify the link, you have to mostly focus on cosmic events first. That's why we have, in the latest, in the last 2 years, we tried to focus on cosmic studies, where, of course, you have this facilitation of densification of data and also the higher temporal resolution by 1 second, let's say, time resolution of these GNSS networks. So we are focusing on the early effects of the earthquake, where they are generated by the PNS waves, which are not very strong, but following the Rayleigh waves, which have a certain polarization that allows for this wave to have higher impact through the decrease of the, like a tsunami effect, through the decrease of the density. As you go up, the amplitude of the wave increases. So if it's actually a daytime effect, if it's a daytime earthquake, so the ionosphere is not very high, around, let's say, 200 kilometers, and the electron density is higher as well, then you are in the position to possibly detect manifestations of these events based on these total electron content variations. So the idea is to measure, let's say, in 8-10 minutes from the big shock, the wave reaches the ionosphere and then it travels along the magnetic field lines to affect the ionospheric pierce points that are the ionospheric points of maximum electron density around, let's say, some groups identify 350 kilometers, some other groups 300 kilometers. And a typical scenario, which is the ideal scenario, is Japan. That's why I want to show this this animation, which demonstrates real data of these waves emanating from the epicenter, and so you can see that you get a real effect, real tsunami effect in the ionosphere by this dense network of GNSS stations. So these are actually around 0.5 to minus 0.5 of an amplitude of to the electron content units. So it's not very much if you consider that, let's say in Japan you get something like 70 tech units of electron of TC units, let's say during noontime when you reach the peak. So just to replicate this framework of study, we have recently studied the well-known Turkey-Syria earthquake, which was one of the most devastating events recently. So actually we are lucky in the sense that, this is what I would like to highlight, to encourage the community to exploit the GNSS reference networks. I mean, in Cyprus we are very lucky to have this CYPOS network, which can give us pierce points in the ionosphere around, sufficient pierce points around the Eastern Mediterranean, but still it was very challenging for us to isolate a certain path that would give us the maximum effect, the wave activity effect, I mean the cosmic effect. And this was the case with that particular, the previous path, satellite path that I showed. So we were able to really register all the waves with respect to all the pierce points viewed from all 5 actually stations that were operational at the time. So this is an encouraging from a scientific point of view, but also from an operational point of view, in the sense that if you are certain on the level of the disturbance that you can monitor seismically, then you have more, let's say, more coherence in your studies when you are trying to detect precursor activities, which is of course a big question, big discussion, because Jordanis and I also studied with your predecessor. It's very, very questionable practice, let's say, to inform people about an impending earthquake. I mean, the community knows that better than me, I guess, and causing havoc and stress, yeah, if you are not really certain what is coming. So that's why the scientific research of the topic is quite important. And then this is our main instrument, this is our radar, which help us to monitor the ionosphere 24/7. So we get every 5 minutes the virtual heights of the ionosphere, and then we invert this ionogram to get the electron density profile. And we are able to identify specific signatures through this study. These are called multi-cusp signatures. So we explain those in the sense that you get these cusps, additional cusps, the ionograms that I showed you before, and these actually infer perturbations in the electron density profile with respect to altitude. And we are very surprised to be able to detect this not through our, let's say, radar-based remote sensing technique over Cyprus, so we get this very, very significant distortion of the ionogram, let's say approximately 9 minutes after the second shock of the Turkey earthquake. But we were also able to extend the study all over Europe and exploiting GNSS networks in Turkey, Greece, also our 7 stations here, but also other relevant instrumentation like seismic stations and the other radars like ours that are operational over Europe, and detect those multi-cast signatures in radars extending up to Germany and the UK. So those are very, very distinct signatures. We don't observe them in any other ionospheric-based variability scenario. So they are quite special, and we were able to correlate this with the manifestation of the Rayleigh waves arriving at the seismic stations on each of these collocated radars that I showed you before. You can see a certain coherence, of course, with a specific uncertainty of the measurement, which is approximately plus minus 5 minutes, because every radar takes some time to infer the ionogram. It has to measure on specific frequencies throughout the whole age spectrum from 2 to 20 megahertz. But you can see a coherence in the time delay, which serves to solidify the assumption that it takes, let's say, 8 to 9 minutes for that disturbance to appear in the ionosphere in the sense of the form of multicast signatures. And then we have exploited these tracks that I showed you before of more extended networks, trying to measure the actual speed of the Rayleigh wave as it appears in the ionosphere. And we were able to identify splitting of the wave, which has been reported in the literature before. We were able to identify the fact that you get different velocity. So it's not let's say, it's a dispersive, in a sense, medium in the ionosphere, the way that also record the measurement of 2 frequencies here. But we also get the inhomogeneity in the characteristics by exploiting these techniques. So you can see that the wave has certain n-type properties that we are able to follow through an extended, let's say, spatial area around the earthquake. But of course, this is the near field. So in the longer distances, you are focusing on different effects like the multicast signatures I showed before. So, I mean, okay, this is a bit too scientific maybe, so it's beyond the scope, but what I want to finish off is with the message that the same techniques can be used to monitor the troposphere. So we can use these techniques to monitor, if we have the low-cost approach, if we try to convince, let's say, the community to deploy these low-cost networks of GNSS networks, then we can really exploit them also to monitor the variability of the troposphere, which is manifested in the excursions of the precipitable pole water vapor, which is embedded in the troposphere and can lead to severe heavy precipitation events that can generate heavy floods. So these are remote sensing techniques that can also be used for nowcasting, short-term forecasting, and in the general scope of post-event analysis of this, let's say, activity. Thank you.
I don't know if we have any comments or questions. Actually, I have one. So can we somehow get any information before an earthquake happens and maybe do some predictions?
Yeah, I mean, this is a big discussion in the community. There are a number of, let's say, 20-30 groups in the community that are actually offering this as a prospect. There are other, let's say, 20 groups that are actually rejecting this approach because there is this coupling effect which doesn't appear in every layer. So there is no discussion whether it's not apparent in our instrumentation. It's there, but it's not apparent. But the consensus in the community is that you get 6 to 7 days before an earthquake, if the event is going to be quite strong, and also if it's let's say around up to 40 kilometers depth, specific manifestation in the orientation of the slip, you are in the position to get sort of not prediction, but an indicating effect that there is an impending event to happen. But this is a big discussion.
Yeah,
so it's not very mature.
Yes,
Discussion also in big area.
Yeah, I mean,
Geographical area.
you have the
Not
preparatory
like
you have the preparatory area that is by the Tukhogosky formula, you get this. But of course, you have to have the instrument there to measure. So in America, in San Andreas, let's say, area where they have deployed this very dense instrumentation, they are more confident.
You remember all the polemic for L'Aquila earthquake? There was one scientist that was saying that he could premonitor by the measure of radar of his Actually, the point is that this is true, it's proven scientifically, so it's a good way of research, but to say that we are prepared to use it for evacuation of an area because an earthquake is coming, this is a long way.
Yeah, but it's an additional, let's say, point that you can consider in a multi-framework where you can have a neural network, let's say, firing towards a higher certainty.
Yes.
So it's a matter of lack of data, basically, that prevents you from making the more precise associations,
Yes, because when on case studies that you have sufficient and very dense spatial and temporal data, you get very confident results. So that's why you are promoting the low cost option.
Yeah.
Thank you.
Thank you.
Quantity in Cyprus. Total inhabitants of more like 84,000 people. Last day was one amongst of the most challenging days that we faced in Strogolos because we have a small time precipitation yesterday, and unfortunately the precipitation was very high. And we had to go in multiple areas in order to somehow safeguard the infrastructure or somehow to help people in order to not to flood within their houses. We get about 150 calls from the people that we are flooded, please come and help us, and etc. Us and the fire department. So, as you said before, and the other professor said, there are a lot of castles around to whom it is the responsibility to react, to whom is the responsibility to organize, to whom is the responsibility to somehow safeguard the infrastructure. The other problem that we have is that the infrastructure due to the climate change, it is under-designed, especially for the rainwater, how to collect it and how to safeguard. But because Petros told me for today have to be very fast, I brought only the part that we have on the building inspections that we are doing. It is we just finalized it yesterday, last night. We had to come up with 11 buildings within Strogolos municipalities, buildings that were built between 1976 to 1982. It was for the people that they are refugees in Cyprus, the people due to the Turkish invasion, they had to somehow live within Strogolos, Lakatamia, or Limassol and Larnaka. And I will show you the buildings that we actually this year we came up in order to inspect them and to tell them now that they have to be demolished. In a certain days, like 90 days, you have to go out from the buildings and you have to go somewhere else, and the government has to build a new one. The problem that we as the municipality of Strogolos, we need tools like ISTOS, like other tools that we want to have in our hands in order to prevent from buildings to decay like that. We need the communities, we need the scientists to give us, we have AI, we need the specific tools to help the municipalities in order to, not only to prevent, to pre-act, because we're not going to prevent something like a seismic effect, but we want to actually, I don't have an agenda, I don't have in my hands, I don't know in which condition the buildings are. We have to deal with around 10,000 buildings within Stakeholder's area. So imagine, it took us like 3 weeks in order to see 11 buildings, and 9 of them, they have to be demolished right now. So we saw many things like humidity within all the buildings and all the apartments. I'm going to show you that all of them livable. People are staying with it. We examined like 92 apartments within the area of 1 square kilometer. So it is totally different. You can see cracks wherever you can see cracks. You can see cracks within the main stairs, you can see cracks in the building, in the walls. We have, unfortunately, many cases that even when you kick it, and this is the second floor, everything by itself, the self-weight cannot withstand now, not even an earthquake. So the problem for us, it is how to prevent that, how to react on that, how to inform people that, okay, I have this idea of your building, maybe a building information management tool that we can actually inform the people that you have to do those specific things, or else it is dangerous for yourself and for the society also. This is the base column of the building. We actually saw, as I told you, 11 buildings. The problems were numerous. You can see the decarbonization even from itself, from the structural strength of the irons itself. We can touch it and you can break it like a biscuit. That was the problem that we saw in several other cases. This is an actual room within an apartment. The humidity has already rotten everything within the apartment. They had just closed that room and they were living on the other part of the building. So we are facing a war out there. Municipalities are the epicenter of the people that when something happens, you call the police, the army, and the municipalities. Because the government is on the top shelf of the level and no one is, if you call the government, who will respond? So the municipalities are taking all the pressure in order to ask, in order to react, in order to check what is going on and what are the further steps that's going to be. One of the ideas that we had, they somehow with a still column, they said, okay, we are going to support the 2 balconies, but as you can see, the balcony, when you see it, you can see already we have an inclination of like 10 or 12 degrees. So we urgently need to have tools in order to safeguard the people. That is what we are asking from the community. As I told you, 10,000 buildings plus within Stakeholder municipality, and these are only 11. And we did 3 weeks in order to examine them. So the theory, it's on the one hand, it's a very good thing to cover the theory and how we can collect the data, but we are here. The war is there. And the everyday, I'm not so dramatic, I am just realistic about that. And the problem that we see, and we ask from the people, from the community, especially with the Frederick University, we have a very thorough relationship, and we need to have, and as I told to Petros, we need to have a memorandum of understanding how we can collaborate with ISTOS, how we can collaborate with other programs in order to proceed and to not to have the knowledge how to fix them or how to demolish them, but we need to have the knowledge and the tools not to go there. That's the main idea for us. And I can show you numerous. You can see by only how this one is standing. We were 2, we were a friend of Andreas Theodotou. I am 110 kilos, the other guy is like 100 kilos, and we said to one another, one can be on top in order to examine that. And imagine there are families beneath. This is the second level of the building.
And the strength, sorry, Naso, and the strength of this, the resisting system is more or less 5, 6 MPa, 7
Not
MPa.
even. In this case, this is the ground floor. This is one of the main columns of the building. You can see my hand, and you can see what is now the strength and how is the quality of the iron within. This is the main column of the building. Ground floor, not second floor, ground floor. So imagine from the self-weight, the building itself is already finalized its own lifespan. So I will finalize my presentation with that we are determined in order, as a municipality, to seek help, in order the community to give us the tools to continue to present to the people, because also the people by law, the people that have the right, they have to know, and the municipality, I should tell them that be careful, your building is going to collapse, or your building is coming up in the next 2 or 3 years to be in danger, so you have to take measures. Now I will be in the position that in 2 weeks' time, from the municipality and the municipal council, I will say that those buildings are now under in 3 months' time have to be demolished, so you have to go out from there. And you can imagine that a lot of those people, they cannot actually stand, they don't have the money to go to rent or to live somewhere when the government will come in to rebuild those buildings. So, I don't want to...
Well, the overarching political question here is how can we allow this situation to become? I mean, here is the ultimate moment. I mean, we are discussing this, and this is after the fact.
You know what's the problem? It is what we told before. The fragmentation of the many systems that are going in parallel. For example, here is the authority is the town planning department of the government that owns the building like 20 or 30 years ago. They gave them the permission to stay there without actually maintaining, and they gave them also the title of that this apartment is yours now. And by law, it's coming to the municipalities that the municipalities have to check on that. With zero budget on how to maintain, on zero budget on how to prevent it. And then come again by the government, the directive that you should have to change all the systems. So the thing that you told us before, the fragmentation of decisions and the making, and when the building is going, let's say it's going to collapse like in 2 months, how I will need the help from the people of the government in order to rescue it, and then what I did to prevent the whole thing. And I'm telling you, it's only 11 buildings. The whole system, it has more 75 buildings.
I know the reality of the situation. I come from a refugee family, and this bothers me. This has been an issue that has been repeating over the years. It saw the light of the news several times, and yet nobody takes responsibility to do anything about it. And most of these apartments, people over 80 years old live. You know, this is a shame on our society, and we come here to show these pictures and whatever.
No,
I'm showing these pictures. It's just an excuse of this fragmentation of responsibilities. We see this fragmentation of responsibilities in all levels in Cyprus, environmental issues, economic issues.
But we have to act now.
Obviously.
That's the thing. I'm just being realistic, and so not too dramatic, but more realistic in that, to ask for the community in order to help us, not the government, not the police, not whoever maybe have the wishful thinking, but by law, we are, the municipalities are responsible on how to pre-act on that. Not only to react and we say, okay, what you did all those years, nothing. I'm in a terrible situation now, and I have to send the letters to the families there to tell them, go out now. And what you have to do, just to go one step behind and check until the next buildings will happen, and to be in a situation like that, I have to have the tools to run against the time in order to prevent from those things that will happen, not in the same magnitude, not in the same analogy, but to somehow react in, let's say, in the 10% of the cases. Thank you very much for your time.
Thank you, man. If I may add a quick comment to Bernard's presentation, which was very realistic and shocking, if you ask me. And this is what we went through when we first started observing these buildings. If you remember, I sent an email at some point and I said that we should go around these places and see these buildings and try to find ways to visually assess them. And I mean, it was a bit of a last minute suggestion, and eventually we didn't go through with it because it was complicated. The bottom line here is that, as I said many times, we have construction in Cyprus that is much worse than where you come from, and that's finished. The reasons, many. The actions, very few. The political system is not favorable and is not actually trying to assist the situation because they are seeing things differently. You know, depending on the votes, they try to help everyone who's voting, and these people don't have a lot of. They cannot do lobbying against any political party. You know. So it's a problem, as Christos says, a problem that is going on and on for years and years, and there are many ministers of interior that should be accounted for where we are now. Now the thing is, we have like 500 buildings like that that we have to. Yes. 43 of them have been deemed as to be demolished. 23 of them will be demolished tomorrow, and the rest 20 of them probably by the end of the year. For the rest of them, who are maybe not in such a bad condition, we are trying to find ways and assessment forms and methodologies for such type of buildings. Not the ones that we saw in ISTOS, which is probably B, C, D.
But this
is not B, C, D. This is Z.
This is that one.
This is that one. So
that one.
we are trying to find methodologies.
Another problem.
It's another problem. It's totally different.
Yes.
This is concrete strength 3.
Yeah, you could find a
carbonation depth of 90 millimeters.
You could try to fix up some form.
Do you have anything in mind?
Some form to say for each of those problem, which could be the strengthening or the action that you can do for each of those. It depends, because this is obviously, as he said, okay, forget about that. But there are some others that are ongoing where you can act before this situation. I mean, is showing completely in their own danger situation. So it's a problem is something that you can organize in time, so that the 500 buildings that now is will not arrive at this situation.
Will not reach this level, yes. That's one of the questions and one of the requirements. The other one is we need a way to assess which ones should be demolished.
Yeah.
And the formula we are using cannot be used for such buildings.
No, that's for sure.
That's why I'm asking. When you go back, look into it. If there is anything you guys have for really bad construction that is borderline collapse, or that should collapse, or that should be left and strengthened, but at this level, I'm not talking about construction we saw yesterday, please communicate to us.
But this is a very important point that he was saying, okay, these have to be demolished. Yes.
Yeah.
Tomorrow we'll demolish 23, then the next month another 23, and so on. But we have a problem all around that is, huge. So, and probably is not all at this level of damage. So, what can we do in order then, in order to prevent, in order that at the end of the day, those 500 will become 200 or 150 or what? So, and to do that, the approach is completely different from what we have said. All this
That's why I said
summer school.
Think of it, and we'll be in touch because we will need it soon.
Yeah.
We are starting the inspections of the rest of the.
Maybe with the help with AI tools, maybe someone has come up with a solution with a fast structural analysis strengthened tool that we can actually, not to come in 5 years, I mean, in 5 years of the time to be here again and to say, what we did,
you'll have to set this.
so just to prevent at least a 10-15% of that, we can prevent of something going worse and worse
To have
per days.
to have a clear priority.
Yes.
There is something that has been done recently in Italy that is a campaign, but not for a specific building, general campaign, that is called, vabbè, in italiano, diamoci una scossa, give us a shake. That was, you see, a sort of play of the wording play to say that we have to do something to answer to problem of very vulnerable buildings that are standing there without having the consciousness of that. It was a form where you could detect a series of vulnerability factors, as we say. I make some example. Reinforced concrete is framing one direction, sub floor, or all the cover of the building, or the stirrups broken, and so on. So a series of vulnerability factors, and to give the sum up of all the vulnerability factors, you could have a risk table, green matrix, green, yellow, red, in order to say, okay, this is something that you have to investigate and to decide what to do. This is for the owners, of course, but this kind of analysis could be done a bit better, more precise, more customized on your case, and but at the end of the day, there is always the same problem. Who pays for that?
That's a different story. I mean,
it's a different story.
Look, at the moment,
it's always the
and
same
in all
question.
fairness, and I will be fair because it's a very strong point at the moment. The Minister of Interior is actually doing something.
Okay, available.
He's giving some rents for 2 years.
Okay.
He's paying for the reconstruction.
Okay.
He's asking these people to pay partially 10%
Yes.
for the reconstruction, which I don't agree, but that's not me to us.
Is reasonable.
He's giving some money. It's about 60-70 million.
Okay.
For these 23 buildings.
Okay.
So he's giving them like 700 euros a month to go and rent somewhere else for 2 years until the next target. Now, if they can find in Limassol to rent with 700 or 800 euros, I don't know. But at least they are doing something even at this stage that we are at the moment. And then we'll give them a new apartment, of course, when it's finished, which again, it's a plus. But anyway, the paying is something that the government is trying to sort, and there are problems and everything, but the bottom line is, you sent me something on what you defended before, and we'll be in touch. I mean, we'll need...
So has to identify cheap intervention or retrofitting that could save, the people, because basically, and the society, as you said, because this is possible.
We'll talk with Kyria as well.
On the one hand, we are responsible as authority to prevent or to say to the people, okay, be careful, your building is starting to be in danger, or I can see, because only I can see, I don't have the tools to go inside, I can see that some things are happening, so please do something from that.
And to give some suggestion, this is important, to avoid the case of retrofitting that I saw the pillar at the end of the balcony that is completely wrong. It is even worse. It's better not to do it, because it changed completely the static scheme, and increased the loss. Sorry?
They did these things themselves. They own it.
No, I know, but just to give, you see, some address and some suggestion of which could be the cheap intervention for reducing at the moment in, you see, waiting for an important decision. You can stay there by now, but
yes, and on the other hand, I'm from that way to start building a database of the building identity. So I know that I have buildings since 1940s. I didn't show you the area of the city of the Stakeholder area that have the historical buildings, but also
Not for only
Many
historical
people,
one,
many
residential,
buildings on the, maybe in worse cases like that, but they have to be preserved. That's a totally different story. But I have to find a quick tool in order to collect the data and to come up with a database of the building site identities in order to gradually bring up a solution or somehow a tool in order to address the people. Because I am the responsible one on that. That's the main idea, that's the main problem that we are facing.
No, of course. Thank you.
Thank you, Nas.
Of the Cyprus Seismological Network. My name is Jordanis Dimitriadis. I'm working as seismologist in the Cyprus Geological Survey Department. Our department is a very small department. Its scope is the geological matters of the Republic of Cyprus, but we don't have enough personnel. In my department, in the seismology section, we are working only 2 seismologists. So, okay.
You are with Silvana?
Yes.
You and Silvana?
Yes. The only 2 seismologists, and we have another 4 people, technician and for honeymoon.
So you are 6?
6, but the other 4 people are not
technicians. Okay.
Yes. They are not experts on seismologists.
Okay.
Okay, this is the seismological network of Cyprus. Consists of 14 seismological stations, of 14 accelerometric stations, and 2 independent seismological centers. We have 12 inland stations and 2 offshore stations within the Cypriot economical zone. This is the strong motion network. Consists of 14 accelerometric stations. 5 of them are installed in the 5 major cities of Cyprus, in Lefkosia, Paralimni, Larnaca, Nemesos and Paphos, and 9 of them are installed temporary in the Polis Kyrtsochous area for collecting data for the ongoing microzonation project of this area. All the installations of these stations have been made in the ground basement of buildings, 1 floor. Okay? This is a typical installation of an accelerometric station. Regarding the Cyprus Seismological Network, as I mentioned before, we have 12 inland stations. The selections of the sites that we have installed these stations is based on 3 factors. The first was the best network geometry, namely to have the best possible coverage of the island, considering the fact that the northern part is occupied. So the northern station is Athalassi station here in Nicosia. The second factor was to find quiet locations away from cities, roads, industrial areas, ports. And the third factor was to find good geological conditions, soil conditions, actually to install all the stations in solid bedrock if it is possible, obviously. The 11 stations land are from our department, but the 12th station belongs to Geophone Global Network. Geophone is the seismological network of Geophone's Potsdam, Germany. It was installed in 1998 in Mathiatis village, in this place. And the 2 OBSs were installed in 2013 within Cypriot economical zone, and they are connecting to the main land through an undersea power over Ethernet cable transmitting real-time seismic data in two places, in two landing stations, in Geroskipu and in Pendaskinos. A typical installation of a seismological station consists of the seismometer, which is buried in a vault deep around 1 meter, depending on the bedrock. In this vault, it was also made by ourselves, by our department, the vault and everything, except, of course, the equipment that was provided by a company. In the vault, we have installed also the digitizer, which digitize the ground motion and converting to digital sign, to digital signal, sorry. And this signal, through the cables, ends in this box, in this white box, which is inside the satellite modem. We use satellite communication for our network. So through the satellite antenna, we are receiving the data in the two seismological centers. All the stations are autonomous regarding the power system. So we have installed solar panels and batteries to sustain the power health of the station. We choose the satellite connection because Cyprus is a very small country, and in the case of a strong earthquake, when all people used their phones, so we have the communication system collapsed. So the satellite option, it was very expensive, but it is the most efficient to work in a small island like Cyprus. The main theory behind, or the main scheme of this network is each station to send real-time, near-time data through the satellite. We use a private satellite network. Do not share the carrier. Okay? In two seismological centers, one in Lefkosia, in our department, and one in the Mathiatis village, that it is installed also the station of GFZ. This communication is two-way, so we have the capability to remote monitoring and maintenance the remote stations. Okay, this is the primary seismological center at Lefkosia. It is located on the 6th floor of a 9-floor building, built without any anti-seismic law. It was built in 1992 or something, so before 1992. Okay. That's why we have upgraded the seismological station in Mathiatis. Okay, it's unmanned, obviously, but every operation that hosted in the main seismological center, we have replicated in the backup center. So we have everything work there 24 hours. And also we are totally dependent because we have also installed a power generator in the case of electricity disruption. And for security reasons, we have installed security cameras to monitor the station inside and outside of it. Both centers support the reception of continuous seismic data by our network, by stations from neighboring countries, and we are receiving data in real time from 70 international seismological stations. There we have an automatic system for automatic processing the data. When this system detects an earthquake, a possible earthquake, immediately, within a few seconds, disseminate the preliminary results through SMS, email, and through websites, only to a few people, only to us, seismologists. And then we go for the manual event post-processing using the appropriate software. And when we have the event location, the earthquake analysis, that means the event location, the magnitude estimation, we disseminate the information through our website, through social media, through emails, through faxes, in every possible way. And of course, every information about the earthquakes are in our public website, which is accessible from every device, from every place of the world, and contains also the real-time seismic recordings for each station, including the accelerometers. We also, in our website, we have our complete earthquake database since 1997 that was installed, the first analog network. And we have also the information for historical earthquakes. As we can see, the seismicity of Cyprus is gathered in this cluster in the offshore of Paphos area. That it is also the Paphos Transform Fault. If you are familiar with the seismotectonic setting of Cyprus, it is the so-called Cyprus arc that has 3 segments. The western segment, that it is from Antalya Gulf to Paphos area, that has high seismic activity, as you can see also from the epicenters. The central segment that has also high seismicity but with shallower earthquakes, and the eastern part that have very low seismicity level.
Which, however, is related to the recent.
Not really. It was the Latakia fault that I am referring. The recent earthquake what happened in the East Anatolian fault zone, that it is like the different fault zone. Okay, it's connected,
It's
but
connected in a certain degree.
in a certain way. But even though after a so huge event with many aftershocks, until today we have aftershocks from this area, we don't have located earthquakes within this Latakia ridge, with the eastern ridge. The most events that we located, it is only in Turkey-Syria border region, in Latakia, not Latakia, in Adakia city.
I think that even for Giulio and the others, it should be nice to complete this nice figure with the presently known fault systems.
Yes, in our website we have mapped every neotectonic fault system.
The main.
The main. So you can, it is not very clear in this picture because it was overlapped by the epicenters of the earthquakes, but we have the Paphos thrust system here in the Paphos area that has also the well-known epicenter of the earthquake of 1953, which was the most destructive earthquake in Cyprus. And we have also mapped the Arakapas fault system here in Limassol Forest and the Gerasa fault system, which is the epicenter of the 1999 earthquake in Limassol, also a big event, like a 5.9 event. And you can see also this cluster of the epicenters in these 2 main fault zones. And also, this is the fault zone of Iopetri fault zone that it is recently studied within the framework of the microzonation study of Amorphous area.
And this may be quite important.
Yes, it's quite important that this fault zone produce every year an earthquake around 4. Okay, we have in 2021 5 there. We have in last year in this area an 4.5 earthquake.
Yes.
Okay. But okay, the level of seismicity in Cyprus, it's lower than in Italy and in Greece, obviously.
Yes, but
The largest earthquake, the most recent strong earthquake occurred in the Cyprus was the strong earthquake occurred on 11th January 2022, last year. It was 6.5. It was felt across the island very strongly. Also felt in neighboring countries like Egypt, Turkey, Israel, Syria, Lebanon. The main earthquake was followed by many smaller events, 168 only in 2022. Okay, most of them the magnitude were bigger than 3. Okay, and the most strong aftershock, it was occurred on a few days after the main shock on the 2nd of February on 2022 with magnitude 5.1. For the main event was issued a tsunami alert, and this tsunami alert also was in the level of advisory for 3 sites in Cyprus, in Paphos, in Polis, and in Morpho area. Advisory, it holds it is meaning that the earthquake of this size had the potential to generate a tsunami that can strike coastlines with a wave height less than 0.5 meters and can cause a tsunami run-up less than 1 meter. Obviously, we don't have any actual observations or reports for tsunami. Okay, it was this the alert, the prediction after this the occurrence of this earthquake. So in this point I will I will present you some information about the NEAM tsunami warning system that is active in our area. This tsunami warning system was created by UNESCO, by the Intergovernmental Oceanographic Commission, IOC of UNESCO. It was first installed or created for the Pacific area after the occurrence of 1960 Chile earthquake, the big earthquake 9.5. Create a big tsunami in the Pacific Ocean. But after the tsunami in Indian Ocean in 2004, UNESCO has created 3 other systems in Caribbean Ocean, Caribbean Sea, in the Indian Ocean, and in the Mediterranean area. I think this is a small video that explains the system, how it works.
We know that there are millions of people living along the coast and walking along the coast around the world. So these people are potentially at risk to tsunami. So if there was a tsunami, it could be catastrophic.
Cyprus, this system is implemented through the National Committee of NEAM-WS. This committee has been established in 2016. The chair of this committee is our department, which serves also as Tsunami National Contact. Civil defense is the tsunami warning focal point that is receiving the alert from the tsunami service providers. Okay. And member of this committee is the Department of Lands and Surveys, which is the National Agency for Hydrographic Issues and operating also the National Network of Tide Coaches. Observers of this committee are the Oceanographic Center of University of Cyprus and the Cyprus Marine and Maritime Institute located in Larnaca area. Our department, as Tsunami National Contact, contribute real-time seismic data to 2 tsunami service providers, to Italy, INGV, and to NOAA in Greece, to the National Observatory of Athens. And civil defense, as tsunami warning focal point, is receiving tsunami alerts from 3 accredited tsunami service providers, from INGV, from NOAA in Greece, and from Koeri in Turkey. And within the framework of this committee, our department is now participating in an IOC project. Actually, we are the coordinator of this project called Coast Wave, which has started on December 2021 and is going to end on February 2024. And the main objective of this project is to strengthen the resilience of coastal communities in NEAM countries and to tsunami and other sea level related hazards. In Cyprus case, the municipality of Larnaca has been selected for implementing this project, and hopefully at the end of this project we have in Larnaca detection, monitoring and alerting systems installed there and in operation, and Larnaca will be the first Cypriot city recognized by UNESCO as tsunami ready community. To implement this project, we are covering 6 main components. The main component is the public awareness. This task includes the understanding and communication of tsunami risk in the municipality of Larnaca. This was achieved with the conduction of risk perception studies. This task was performed by our partner, the Frederick Research Center. The second component is understanding the tsunami risk. That means that we are going to make an assessment of the number of people at risk in the tsunami hazard zone, and as well as the identification of economic, infrastructure, political and social resources. This task will be undertaken by Cyprus University of Technology, which also is a project partner. The third component is standard operating procedures, that it is a civil defense task that is going to prepare a community and a national tsunami emergency operations plan, as well as the capacity to manage emergency response operations during a tsunami crisis. The fourth component is tsunami modeling and evacuation routes. We are going to map the tsunami hazard zones and designate it, along with easily understood tsunami evacuation maps and tsunami information science instructions. This activity is ongoing by our department in close collaboration with the other members of the NEAM-WS National Committee. The fifth component is the infrastructure. We are going to install tsunami detection and alerting equipment in Larnaca, in the Pinkudes area in particular. And this activity is pending and will be completed mainly by the municipality of Larnaca and CMMI. And the sixth and the last component is the public education and training. That means that we are going to public outreach, organized educational activities, and at the end of the project we are going to organize, with the collaboration with civil defense, a community tsunami exercise in order to be Larnaca a tsunami-ready community. So that is from my side. I would like to thank you for your attention, and we have Facebook and Twitter and our websites to follow and to inform for our activities. Thank you.
Questions, comments? You want to go first?
So, Jordani, taking into account the operational requirements to implement, let's say, procedures for alerting tsunami. So, what is the delay you have to adopt?
Okay, this is a very short presentation. We have 3 tsunamogenic areas. That means areas that can produce big earthquakes that can impact the Cypriot coastals. The first, it is the area of the Hellenic Arc. That is, we have enough time to react, because a big earthquake in the Hellenic Arc, nasal side, on the western part or the eastern part, the tsunami wave that will make like 40 minutes or 60 minutes to reach Cypriot coast, so we have enough time to react. The second area, it is the Cyprus Arc, but because the distance is very close to the coastal area, we don't have enough time, like 5 minutes to reach the tsunami coast. And the third one is the Levantine area, the coastal area of Israel, that we have a tsunami there created in historical times through due to a submarine landslide. It was a big earthquake in the Dead Sea Fault, and was created a submarine landslide that created tsunami. Also from this, they have some studies there, and they estimate the time around 25 minutes.
Yes,
so it is depending where the earthquake occurred. Then, if the system it is going to be implemented, because nowadays civil defense has not any standard operation procedure. They have not like a plan how to react when they receive the tsunami alert. So if we are going to place civil defense this plan, then within a few minutes they are going to activate the alerting systems, like Ftihia presented in the morning, the system like sirens or the SMS notification or whatever.
But the most important, I think, problem we have, I mean, for this is a UNESCO-driven project, yes?
Yes.
So does Turkey participate in this?
Yes, it was also a first member of this.
I mean, taking into account the experience from Fukushima, for example, where the main driver for the failure was a tsunami, not the earthquake itself.
It was the underestimation of the magnitude of the earthquake.
No, but the tsunami which came in actually dysfunctioned
it was,
the
earthquake was very big. It was once per 1,000 years.
I know, but it's enough to wipe out Cyprus. Considering the nuclear plant that is under development, that's why I'm asking.
No. We have different measures. We don't expecting the same tsunami like in Pacific Ocean. Mediterranean Sea is it's different.
More mild. But in terms of the magnitude of a possible earthquake at the faults that you demonstrated,
yes.
Turkey-related faults,
yes.
the climate development and the Turkey in the north.
Okay, because I have this slide here. This is the tsunami in Iskenderun, in Alexandretta, from the big earthquake in Turkey. they have flooded the Alexandretta earthquake, the Alexandretta port in Skenderun. It was flooded due not the earthquake, because the earthquake was in land, on land. So it was not like by definition created tsunami. It was created. Okay, let me laser. Sorry. It was created a submarine landslide in this area, and that created the tsunami that also reached in Cyprus. We have from police, border marine or something, marine police of Cyprus, we have information and reports that the sea from this is the Paralini harbor, okay, and the sea was drawn inside and the bottom was exposed after the earthquake. And from Lancet, the survey department, we have an observation in their instruments around 60 centimeters in the Paralini station.
So there are two mechanisms, in the sea or at the
Submarine
coastline.
landslide, yes.
Failure of the coastline, I mean,
Yes,
last time
exactly,
the
yes,
coastline.
because it was a huge earthquake.
So you have to map,
Yes, that's why we are in collaboration with colleagues from the university, from NOAA, National Observatory of Athens, and INGV and University of Spain, to map every possible source for tsunami in our area, in order to have for Larnaca, within the framework of this project, to have the best hazard zones, tsunami hazard zones.
Since the danger is existential from the Cyprus.
Okay.
So do you have, the question is, do you have any way to implement some policy to control, let's say, the parameters of the deployment of the Turkish plan, or to abstain from a certain procedure, or you don't have any information at all about the parameters of the construction?
The parameters, what do you mean, the parameters?
I mean,
the alert level?
No, I mean, you have some understanding of the fault
Yes.
around the area.
Yes.
So you participate in some fora on the
Yes,
hotel
exactly,
level,
yes.
which I'm asking, do they exert some control, which would force the Turkey to provide some
No. It was okay.
Yeah.
It was okay. We are going to political conversation.
Yeah, but
okay,
it's so essentially important.
Okay, it's a political conversation.
Yeah.
Before, nowadays, every tsunami service provider is allowed to send alert to every country in the NAM region. Before that, we have these political disputes. It was Turkey that wanted to send alerts in their region, but the Greek memberships, and of course Cyprus, was objected to this political decision. So every tsunami service provider, every center in Europe, in NEAM region, actually it's 5 nowadays, it's also Portugal, France, Italy, Turkey and Greece. 5, they have a common decision matrix. So this common decision matrix is considering when an earthquake occurs, is considering and issue the same tsunami alert. So Turkey, Italy, Greece, they issue the same level of tsunami alert. They don't issue different alerts or different messages or something.
Yeah.
Yes, please.
Hi, thanks for your presentation. I didn't see, but perhaps I was not, have you any other map?
Yes, we have.
Seismic other map, yeah.
Yes, we have. Actually, okay, I don't.
I mean,
Yogaris wanted to have a 3.5 hour presentation and asked him to do it in 15 minutes.
no, I
That's
mean,
why-
seismogenetic area, attenuation low, return period.
We have an old seismic hazard map.
Okay.
It was established in 1992 and was reviewed in 2004, I think, 2004. maybe Nicolas knows better, and has divided the whole island in 3 zones. Okay, and the most, I think it's 0.15, 0.20, and 0.25.
The coastal side on the south 0.25, Nicosia is 0.2, and you have it? And then Nicosia is 0.2, then I think it's Rhodos area is 0.15. So it's 3 actually.
We have the information on our website, so I'm going to.
Okay.
But it's available, yes, and that's how we
everything that I showed you is available also on our website. Okay. It's a public open access.
The attenuation law that you apply is.
That attenuation law, I don't know, because when this committee was reviewing this hazard map, I was not an employee of the department. It was established in 2004, reviewed actually. Since then, we don't have any updated the map, but nowadays, with the civil engineers, we are going to make an effort to update the map, because they have also different Eurocode.
Yes, but
the map has changed because it was the maximum was 0.2.
It's different. Something is the zone on which you are obliged to get some acceleration for designing.
Yes.
Something else is the expected shaking all around the country, and which are the zones, seismogenetic zones that could provide such a seismicity, and which is the attenuation of. If you want to do a national impact assessment by seismic area, you make the convolution of all these possible earthquakes that come from everywhere, which show the possible intensity with the probability that this happens. So that is, to do this job, we need not a zonation, but the other map that is something else, is the probability.
Yes,
within one area, you perform, intensity, PGA, magnitude, whatever, with the probability in such time. And once you assume that by statistic, by geophysics, study of the fault or whatever, you need an attenuation law in order to make the impact assessment. Otherwise, is one scenario.
Yes,
it's one impact scenario.
Yes, I agree with
It's what's included in the paper I sent you yesterday.
Sorry?
That's what we've done in the paper I sent you yesterday.
Yeah, I saw.
No, that's what you're referring to.
But I was
It includes both probabilistic and scenario based.
We are very small department.
But anyway.
We do not do research.
And there is the European seismic hazard model, where Cyprus, of course, is included.
The one that they showed
But you see, I trust all the study,
but he's the government.
This is the government. This is the
government.
The National Institute of Geophysics. So I was wondering
actually,
if they are producing this.
Actually, our role is strictly operational. We are maintaining the network. We are 6 people, so we have only and maintaining the network, and of course monitoring the daily seismic activity. So we don't have enough time to make research by ourselves.
Do you have a catalog?
Yes, it's available in our website. Yes, I will show you now.
Since 1896.
Since 1896.
1896.
Yeah, 1896.
And you provide your data to the AIDA node in Athens?
Yes. The real time continuous data.
Yes.
But the information for each earthquake is available on our website. This is okay.
Στην ESM δίνεται. Στην ESM δίνεται τις υπογραφές. European Strong Motion Database.
This is our website, okay? This is our website. It's open access. You can access it from your country, from your mobile phone, and contains every event. You see here 15,300 events. Every event and has tools to. Turn to full screen. Full screen. It's Google Map, and you can map the information using tools like this one. If it works, okay. You can put criteria, search. You can see the events. Also, you can see the seismic sequence of the big earthquake in Turkey, Syria. Everything is right here. Okay.
Thank you.
Sorry, can I ask you something?
Yes.
Is it possible from here to download the accelerogram of each?
The
accelerogram.
The accelerographs are available through our website for specific earthquakes.
Yeah. I mean from here.
No, not from here. From this page. Okay, I will show you.
I know from the other.
No, from this node.
Yeah.
Okay.
Are they also in the ESM, in the European Strong Motion Database?
No. With data, we have an MOU signed to send that data.
Yes,
The real time.
So we're sending to NOAA, but not to the ESM.
Because we don't have an MOU there.
We should have had an MOU, but anyway.
Yes, because ESM draws all the data from ADA, so it's.
So it is the same.
Yes.
So
maybe they draw it from there.
Maybe they have it already.
Yeah.
Maybe they have it. We can check it.
But okay, our MOU have restrictions.
Okay. Yes.
I'm not sure about it.
I will check it.
Okay. But we are open in collaborations. We have signed many MOUs with the PAC, the Cyprus University of Technology, with Frederick, with the National Observatory of Athens, with INGV. We are sharing data. We have collaborations because we don't have the time to do research.
Yes.
We make collaborations. We have collaborations with the UK universities, with Malta, the University of Malta, with GFZ, obviously, host the station.
Thank you, Advance.
Any other questions or?
The lunch.
Okay.